Hello, it's time for us to start our last lecture. As we were talking previously about difficult ground conditions, today we'll continue this topic. So, we have already considered difficult ground conditions which were connected with water flooding, surface water flooding, with cars, erosion, abrasion, landslides, and today we will start to talk about sites exposed to seismic impacts. So this lecture will consist of next two parts, seismology and earthquake engineering. So first of all, we'll talk about global seismic hazard, and it's interesting for us to know that more than 10% of the surface is affected to the seismic impacts, and the half of human beings is living on those 10%. If we will start to analyze the history of humans, we'll find out that earthquakes were always near the humans, and wonders of the world shows us this better than anything else. Because from the seven wonders of the world that we know, three were destroyed by earthquakes. It's lighthouse in Alexandria, mausoleum in Halicarnassus, and also Colossus Rhodos, which were destroyed by earthquake in 222 before Christ. And rest of the wonders of the world were destroyed by fires and the flood. Only one wonder of the world still stands. It's Cheopsis pyramid, and it was built 2540 before Christ and stands still now because of its unique form, and because of the ratio between the redistribution of the mass of the structure with the form of the building, because the form and this distribution of the mass are in the best ratio one to each other. So also we have to know that our region is also, I'm talking now about Ukraine, is also exposed to the earthquakes, and we know more than 30 significant earthquakes which were on our territory. We know not much about them, the ancient earthquakes, but we know very good and very much about the earthquakes which took place in last hundreds of years. So we know the Crimea earthquakes, and we know about Odessa earthquakes in 1802 and 1940. To Odessa earthquakes was the intensity of 7 grade, and also we know a lot of 5 and the intensity 6 grade. Here is the diagram of the Odessa's earthquakes, and we can see with 7 grade intensity of the earthquakes. Also we can see the intensity 6 and 5 and 5.5. We know that there are some sources of earthquakes which makes the territory of Ukraine in the most part affected to earthquakes. We know Orantia area, Dobruja area, both of them are located in Romania. Also we know Crimea earthquakes, Carpathian earthquakes, and platformic earthquakes of the territory of the country. Here we can see the map of peak ground acceleration, and most of them are situated in Romania, but we can see also the Crimea earthquakes and the peaks of these earthquakes. Also, we can analyze the territory of Ukraine, and we can see that all of the territory is subdivided in various different parts, sub-platforms, and also we can see one huge Eastern European platform, which is affected to the impacts from the Mediterranean platform, and we can see this pink line shows us the borders of Eastern European platform from Mediterranean platform, and here is the border between those two platforms, which gives the most earthquakes to our country. Here are 5 main sources of seismic hazard in Ukraine. We were talking about it previously. And now it's time for us to analyze the causes of buildings destroyed by earthquakes. Why do they destroyed by earthquakes? It's because of design errors. So it's errors in the which were formed by designers, architects, and structural engineers. It's construction errors. It's errors which occurs during the construction of building. Operating errors. It's errors during the exploitation of the building, and errors of in regulatory documents. We also know that our building codes also has problems and mistakes, and those can lead to the demolition of building due to the earthquakes. And also disregard for seismic hazard. It's a very common cause of the destroying of the building, because some people don't want to consider earthquake probability at the construction site. One can cause earthquakes. It's mostly it's tectonic. It's a joint behavior of various platforms and seismic plates, also volcanic, landslide earthquakes, and technogenic earthquakes. We have to consider the most dangerous source of seismic hazard. It is connected with tectonic, and to analyze the tectonic, we have to analyze the structure of the Earth, of our planet, and we can see that looks like a layered cake with a hardened outer layer and with the softer liquid interior layers, which called core, inner core, outer core, bottom mantle, top mantle, and also we know various surfaces between such layers. Here is the picture of our Earth crust, and it looks like this. It's also light on the outer mantle or top mantle, and these parts of the Earth crust moves in various directions, which lead to accumulation of seismic energy and redistribution it due to the earthquakes, when a really big amount of energy collected in the in the cracks of the Earth crust. Here we can see the methods of interaction of tectonic plates, and the subduction, spreading, and a shift. It's a map of our Earth lithospheric plates, and we have now it's time for us to analyze the mechanism of the mechanical of the earthquakes. And we can see two main points. It's they are called epicenter and hypocenter. Hypocenter is situated on the deep from the Earth's surface, and the epicenter is situated on the surface of the Earth crust. But both of them can be characteristic of the earthquake, because the deepness of the hypocenter also important for us. During the earthquake, we have a deal with 4 waves, which can be divided into main groups. Here we can see the situation which shows us 2 main waves, P wave and S wave. S wave is the secondary wave, and we can see it right here. And here we can see primary wave. It looks like this, and secondary waves move in this direction. So P wave, S direction, and the P wave, we have to know that is the fastest wave, because P is from primary, первичная, and also S is the some slower seismic wave, and it called secondary S wave because it is secondary. And here we can see the transition of the of waves in simple prisms. It is the motion of the prism from the impact of the hammer, and it shows us the movement of the particles according to the P wave. When we look into the S wave, it is the lateral impact on our prism, and it also shows us the movement of the wave through this prism. Also, we have a deal with 2 surface waves. They called relay and lava wave. It is the lava wave. It looks like the movement of the snake on the surface, and this looks like a regular sea or ocean wave. It moves in the direction looks like this. So when we talk about the earthquake, it is the result of 4 waves which impacts on our building structure or also on our lives. Next question that we have to discuss today is how to evaluate the earthquake. It is a very important topic because we have some dimensions for our bodies. It's weight and height, but when we talk about evaluation of earthquakes, it can be evaluated in 2 main waves. By the Richter scale and the intensity scale. Richter scale shows us the energy of the earthquake as it looks like a blast or explosion, and Richter scale shows us the TNT equivalent of the earthquake, like C4 or other explosive material. Earthquake also can be evaluated in Trotil equivalent of the blast. Next, and how can it be measured? It's measured like as the ratio of two main important values. First it is the evaluation of the displacement of the Earth's surface, and the ratio of this displacement with the distance to the hypocenter gives us the magnitude. Magnitude is the Richter scales can be measured in magnitude. So the length is measured in meters and centimeters, also in feet. But when we talk about Richter scales, it can be measured in magnitudes. Also, we have another group of scales. They called intensity scales, and the intensity, it is the visual assessment of the result of earthquake. So according to the amount of the destroyed constructions, cracks, etc., we can make a conclusion about the amount of the grades according to the intensity scale. So intensity scale, it's absolutely visual and subjective scale, which can be measured according to the visual assessment of the consequences of the earthquakes. Main definitions of the intensity scale according our Ukrainian DES2. We have our own scale, but it's very similar to the European macroseismic scale. And we have a ratio between those two scales that we were talking previously, because each earthquake has only one magnitude, but it has a very big amount of intensities. Why is that so? It is connected with that. When we talk about magnitude, it is the displacement of the surface, which is compared with the distance from the hypocenter. But when we talk about intensity, it is the destructions of the structure. So when we have a deal with earthquake, here we can see the magnitude, and nevertheless we are assessing the displacement from this or this place. It can be expressed in one value called magnitude. But also for one magnitude we had in this case 12 intensities, because as it closer situated to the hypocenter, the bigger will be the destruction. But when our building located very far from the hypocenter, the destruction will be significantly less than compared to the building which is situated in the hypocenter, at the epicenter of the earthquake. So, what do we have to do with earthquakes to reduce the losses due to the earthquakes? First of all, it's preparatory work with the people. So we have to prepare people to the earthquake, so they have to know what to do when the earthquake starts. Next way is to predict the earthquakes, but as we know, for today it's impossible to predict the earthquake and its localization. We can make the forecast, but we absolutely have no chance to predict the earthquake and say with 100% probability that the earthquake will be tomorrow or in 100 years. We can tell about the probability of earthquake, but not it cannot be measured as a 100% probability. And also we have our architectural, structural approach to reduce the losses due to the earthquakes. It's earthquake resistant construction and designing. So it is one of the most effective ways to reduce losses, but also it is the most expensive way to reduce the amount of losses due to earthquakes. Now we're talking about the seismic risk. It is the probability of not exceeding or the opposite or exceeding a given level of seismic impact in a given period of time, or the likelihood of socioeconomic and other losses associated with the impacts. Here we can see the map of seismic hazard of the Ukraine. For our territory we have various locations which can be affected to the earthquakes up to 10 grade. Why is that so? It is, as we were talking previously, it is connected with the cracks between our Eastern European platform and Mediterranean platform, which gives us earthquakes on our sites. But what can we see right now? For the Ukraine, we have 3 maps, and those maps are absolutely have nothing common with the political maps. These maps shows us the probability of the earthquake, and the map called Map C gives us the probability of the earthquake once per 5,000 years. When we talk about the earthquake one in 500 years, it is called Map B, and also for the Map A. So according to the to our building that we will have to design and construct, according to this buildings consequence class, we have to define what will be the level of the consequences of earthquake to such buildings, and according to those we have to define which map we have to choose to design the building on this or that structural site, construction site. So, and according to those we have 3 ways: A, B, C map, and according to C map, we have the intensity of the earthquakes 7, but according to this map C it is 8 grade. So with the growth of the numbers of the maps from A to C, we have the significant growth of the intensity, which we have to understand when we design structural elements for building on those at those regions. So also in the Ukrainian code called DBN, we have such a map which gives us an ability to define which town can be exposed to an earthquake of the certain intensity. Also, we have the very important impact of the ground, because ground can reduce the impact of earthquake, and also it can soils at our structural site can decrease the impact of the earthquake on our building because of its strength. So if we have for the all Ukraine maps, and there all the regions are exposed to the intensity which which was defined to the ground, not ground but soils of the second category. But if we have on our structural side first category of ground of soils, then we have to reduce the seismic impact. And from the opposite point of view, when we have soils on at our structural side which are from the third category, then we have to multiply seismic impact to take it bigger, because those grounds, those soils can increase the impact of an earthquake because its structure. So also when we talk about earthquakes, we have to know that we have to remind that all different ground conditions have a common part with other difficult ground conditions. So the seismically adverse areas are the areas which located in the places of possible occurrence of tectonic faults and on the surface. Also, all structural sites with the 15 degrees with incline of 50 degrees are also seismically adverse areas. Also with landslides, karst, erosion, mine workings, undermined grounds, they are also not good for seismic, for the behavior in seismic, under seismic impacts. And also we have to know that the areas which are located in the places of possible passage of meltdowns and avalanches, located in tsunami hazardous areas, they are also not good for seismic cases. And with the fourth category of soils, according to the soil seismic properties as we were talking previously, first category is the best category, because this category gives the reduction of the seismic impacts, and the third category of the soils can from the opposite side increase the impacts of the earthquakes and add an extra grade to our earthquakes. Say if we this according to the map A have 7 grade, then then if on this structural side we have soils from the third category, then we will have to add one more grade and calculate the building on the 8 on the intensity same grades. And the fourth category of ground is the worst. So now it's time for us to understand the general principle for designing of seismic resistant structures. So first of all, we have to design and make space planning of structural solution that as a rule ensure the symmetry and regularity of the destruction of the distribution of masses, stiffnesses and loads on the floors. We can see it better at this slide. with the wall which is situated asymmetrically, and it gives us additional torsional moment which can destroy our building. Also, we have to be careful with the inner corners of the building, because during the earthquakes it gives us the ability to absolutely destroy the building. So that is why we have some solutions for the cases when we have a deal with such inner corners. First of all, and the simplest one is to subdivide building on parts, and this gives us an ability to avoid the cracks in the facade walls during to the possible earthquakes. Also, such solution gives us an ability to make the behaviors of such structures much better. Also, we have to understand that when we talk about seismic impact, it is the collaboration of two main parameters. It's the mass of the structure and peak ground acceleration. And if we have nothing to do with the second, with the ground acceleration, then we have to admit that the first parameter of the seismic force, mass, is absolutely in our hands, and if we will take the easiest, the lighter structural element, it gives us an ability to reduce the seismic impact, because as its weight decreases the seismic impact on the structure. So also we have various solutions such as seismic base isolation, which gives us an opportunity to reduce the impact on the building by using such rubber metallic plates, or such solution which gives us an ability to decrease the impact of earthquake on the building, but through to such elements which gives us the possibility to move in this way. Also, when we talk about seismic resistance of structures, first of all, seismic resistance is oriented on architect and connected with the form of the building. And we have to analyze various structural schemes of the building which are used in earthquake hazardous regions. So first of all, frame building and various variants of frame buildings are very good under earthquakes. Also, we have confined masonry building, which consists of the masonry and reinforced concrete elements, which connect them together and gives the better possibility of their common work. It is produced in the next way. First of all, builders create such a wall, and on the places of intersection of the walls they lose such a hole which can be used to creation of such a column which connect the wall with such a column, and reinforced concrete precast, not precast but monolithic beams. And here is the way it can be look like. Also, infill frame is one of the most widely used solution for structures in earthquake regions. There is the complex structure which consists of the elements which work as a frame under the earthquakes. There is frame tile design. This solution we already know from our practice, so I will not stop on this part of our lecture. Also, we have monolithic buildings with layered walls, which 2, 3 or even more layers. Here they are. So when the walls serve as the framework for the future reinforcement, for the future reinforced concrete. And here we can see the all those structural schemes that we discussed previously. We can see the list of those buildings according to the reduction of the seismic resistance. So the biggest seismic resistance is the building with the steel frame, and it gives us an ability to design them as for non-seismic regions. And here we can see the reduction of the limited amount of floors. It is all of this connected with the behavior structural scheme under earthquake. Next topic that we will have to discuss is reconstruction and rehabilitation, but we'll talk about this later.